In this video, we are going to solve A-level chemistry paper 1, June 2021. June 2021. But before we continue, I want to appreciate those who have subscribed to our channel. But for those of you who have not subscribed, please assist us by subscribing to our channel. Subscribe to the channel, share and like the video. Thank you for taking your time to subscribe to our channel. Let's get started with question number 1. Question number 1, which of the following is Avogadro number? Which of the following is Avogadro's number? A, the number of carbon atoms in 112 gram of 112 gram of carbon. However, before we even look at the questions, I earlier told you with MCQ questions, when you read the question, digest the question very well, solve the question very well, have the answer, then before approaching the answers that have been given by the examiner. So when they say which of the following is Avogadro's number, what is Avogadro's number? Avogadro number is the number of particles. This is the number of particles. We are talking of atoms, we are talking of ions, we are talking of molecules or electrons in 1 mole of any substance. That is number of particles. I'm talking of atoms, ions, molecules, and electrons in 1 mole of any substance. So it must be 1 mole. So let's go ahead and see which of them has 1 mole. Okay, the question says, which of the following is Avogadro's number? A, the number of carbon atoms in 112 gram of carbon. 112 gram of carbon is not 1 mole of carbon. B, the number of oxygen molecule in 16 gram of oxygen. 16 gram of oxygen is not 1 mole of oxygen. 16 gram of oxygen, 1 mole of 16 gram of oxygen is 1 mole of oxygen atom. 16 gram, that is 1 mole of oxygen atom. And oxygen is not is diatomic. So 1 mole of oxygen molecule is supposed to be 32 gram, not 16 gram. So 16 gram number of oxygen molecule is 16 gram of oxygen is not right. The number of electron in 2 gram of helium, that is not also right. The number of sodium ion in 23 gram in 23 gram. We have said number of particles we talk of ions in 23 gram. 23 gram, that is the 23 gram per mole. That is the number of moles of sodium. So D is the right answer because 23 gram. So D is our right answer. D is our right answer. Question number 2. 50 cm cube of 0.01 molar calcium hydroxide solution would be exactly neutralized by 5 cm cube of 0.01 molar hydrochloric acid. There's one thing here. You have been given 50 cm cube. That's the volume of the hydroxide and the concentration of the hydroxide. What you need to do here is you need to calculate the volume. You need to calculate calculate the number of moles of the hydroxide ion. After calculating the number of moles of the hydroxide ion, I got 0.005 moles. Then we need to calculate the hydrogen ions. After calculating the hydrogen ions concentration, I got 0.001 mole of hydrogen ion. Then I said 0.005 moles of the hydroxide ion are in 50 cm cube. Then 0.01 moles of the hydroxide ion will be in what? Will be in 100 cm cube. That is the volume of the acid. That is the volume of the acid. Now we have got the volume of the acid to be 100 cm cube. In order to have the concentration of the acid, we need to do what? We need to divide the volume the moles of the acid by the volume in dm cube. So we need to convert the 100 cm cube into dm cube. And if we convert the 100 cm cube into dm cube, it will be 0.1 dm cube. And the number of moles of acid is 0.001. So now dividing 0.001 by 0.1 dm cube, we will have 0.01 molar, or 0.1 mole per dm cube. So I now have 100 cm cube of 0.01 molar. And if we do 100 cm cube of 0.01 molar, we will have our answer to be D. We will have our answer of 2 to be D. Question number 3. Question number 3 has to do with when burnt sulfur forms a gaseous. When burnt, sulfur forms a gaseous product X, which can be oxidized. Oxidation is addition of oxygen, remember, which can be oxidized to produce a gas Y. So when we add oxygen to it, what will be Y? Okay, gas Y reacts with water to produce a product Z. Now, which row correctly shows the oxidation state of sulfur in X, Y, and Z? Well, this is a simple but a complicated question. It is very simple and complicated. You just need to take your time. Just watch this. Question number 3, just watch this. They said, when burnt, what is burnt? That is sulfur. When burnt, sulfur forms a gaseous product X. Okay, combustion, that is burning, goes with oxygen. When sulfur is burnt, it forms a gas X. When sulfur is burnt, the gas X that is formed is sulfur dioxide. Then secondly, gas X reacts X, which can be oxidized to produce Y. I said oxidation is the addition of oxygen. So gas X, which is sulfur dioxide, it is oxidized. I now oxidize it by the addition of oxygen. When I add oxygen there, what will be what? It will be gas Y that is formed, and which is sulfur trioxide. It is sulfur trioxide. Let's move ahead. Okay. Oxidized to produce gas Y. Gas Y reacts with water to produce a product Z. The product Z. Okay, Y is sulfur trioxide. Then sulfur trioxide now reacts with water to produce a product Z. This Z is what? When sulfur trioxide reacts with Z, that is with water, it produces Z. And Z is what? Z is sulfuric acid. So it is just as simple. They are just trying to describe to you the process of the contact process, production of sulfuric acid, contact process. So now we have X here, we have Y here, and we have Z here. Now they have asked us to calculate the oxidation state of sulfur in X, sulfur in Y, and sulfur in Z. After this calculation here, the value of sulfur in sulfur dioxide is +4. The value of sulfur in sulfur trioxide is +6, and the value of sulfur in sulfuric acid, which is Z, is +6. My rho will be +4, +6, +6. +4, +6, +6, and the answer will be a D. Question for number 3 is D. Let's move again to question number 4. Question number 4. Consider the nuclear reaction calcium plus hydrogen to give potassium plus X. There's a nuclear reaction there. The product X represent A, 4 gamma rays, alpha rays, and 2 beta particles, and 4 neutrons. If you look at this reaction here, okay, we have calcium, we have hydrogen, and we have potassium. Now, our product here is a mass of 41 and atomic number of 19. What has been lost? The total, because from here is 45 and 21. 45 minus 45 minus 1 will give us 41, or minus 4. Then 21 minus 19 will give us what? Will give us 2. So there we have a mass of 4 and atomic number of 2. A mass of 4 and atomic number of 2. A mass of 4 and atomic number of 2 represents a neutron. It represents a neutron because it represents 4 neutrons. It will represent 4 neutrons. That will represent 4 neutrons. That will represent will represent is it 4 gamma alpha rays. It will present alpha. It will represent 4. It will represent an alpha particle, because an alpha particle has 4 and 2, an alpha or a helium particle. So an alpha particle has a mass of 4, has a mass of 4. An alpha particle has a mass of 4 and atomic number of 2. So our answer here will be B. Answer for 4 will be a B. Answer for 4 will be a B. Now let's go to 5. 5 has to do with which one of the following statement is not true? Is not true. Others will be true, but there's one that is not true. It's not true of the line emission spectrum of hydrogen. Emission, that is, something is given off. Line emission spectrum of hydrogen. You know that in the line emission spectrum of hydrogen, there are electrons falling from higher energy level to lower energy level. As they are falling from higher energy level to lower energy level, photons or what we call light. Light is emitted. They can calculate that light in nanometer. They can calculate the light in nanometer. So when an electron drops from a higher energy level to a lower energy level, remember that an electron can be excited. Electron can be promoted from lower energy level to a higher energy level. When electrons they acquire energy, they are promoted or they are excited from a lower energy level to a higher energy level. When electrons they lose photon, when they lose energy, when they lose energy, when they fall from a higher energy level to a lower energy level, they lose energy, and that energy can be calculated, and the enthalpy change is equal to the enthalpy change of the photon. When we talk of photon, we are talking of light. So let's go back to our question. Which one of the following statement is not true of the line emission spectrum of hydrogen? A. If A. If only a single atom of hydrogen were present, then only a single wavelength would be observed at a given instant. B. Several lines are observed because the sample contains many hydrogen atoms that are in different initial energy states and reach different final energy states. C. Each line represents the wavelength of a photon emitted when an electron moves from a lower energy level to a higher energy level. Something is wrong here. A photon, an electron, they cannot emit. It cannot emit. Electron cannot move from a lower energy level to a higher energy level, and a photon are emitted. No, I have told you, when electron move from a lower energy level to a higher energy level, they gain energy. They gain energy. That's why they move from a lower to higher. When they leave from higher to lower, photons are emitted. When they leave from a higher energy level to a lower energy level, they emit a photon. So the statement is a reverse. Each line represents a wavelength of photon emitted when an electron moves from a lower energy level to a higher energy level. No. Photons are emitted when electrons move from a higher energy level, to a lower energy level. When electrons are emitted, when electrons drop from a higher energy level to a lower energy level, photons are emitted. So C is not right. A single electron can transit to different energy level, of course. So you are right. The answer is C. They reverse it. Electrons, when they move to a higher energy level, they gain energy. When they drop to a lower energy level, they emit photon. Okay, so C is the right answer. Question number 6. Question number 6. The standard enthalpy changes of combustion of carbon, hydrogen, and methanol are minus 394, minus 286, and minus 726 kilojoule respectively. From the equation, carbon plus hydrogen, then combustion, then to give methanol. Which expression gives the standard enthalpy change of formation of methanol in kilojoule per mole? This is a serious calculation that needs a serious understanding. So I would like fellow learners to give me time to how you can calculate this, how first of all you can come about this. When you see such a thing, I think I told you that the enthalpy change for a reaction that cannot be got experimentally, you can do it by calculation. It uses Hess's law, and that is why by Hess's law, this is how you can calculate this type of thing. To calculate such a thing, this is what you can do. For enthalpy of combustion, learners, for enthalpy of combustion, elements plus the oxygen will give you enthalpy of formation, the product. Then the product plus the combustion, you will have combustion products. Then element plus oxygen can go directly to what we call combustion product. So now a dotted line is showing how the indirect route. That is, to combustion product, we can live directly from, we can combust the elements and they will have our products. But there's another way, which is indirectly, we will form the products. After that, we combust them to have the final product or combustion product. That is Hess's law. And in order to form our equation, what we do is that the direct root equals to the indirect root. This is the indirect root, which is the dotted line. That is enthalpy of formation plus enthalpy 2. That is the indirect root. Then the direct root is the enthalpy 1. And if we want to draw what the equation has just outlined here, this is the reaction from carbon plus hydrogen, then plus oxygen to give us methanol. This is what we are going to have. If I want you to have this is what we are going to have here. Oh. This is what you can get here. Okay. After applying this is the formula: element plus oxygen, enthalpy of formation to give the compound formed. Then you now combust the compound, or you burn the compound again, you have the combustion product. Or you can come directly. If I'm writing that, this is what you are going to have: carbon plus hydrogen plus oxygen. Now, our enthalpy of formation will be what? This is methanol. Now, methanol again can undergo combustion. I will not put it here because if I put it here, the chemical equation here will not balance. It is on the line. So our methanol will undergo combustion again with oxygen to produce this. There are 3 atoms of oxygen here. These are also 3. We'll undergo this. This is enthalpy 2. Now, so we can now have carbon dioxide and water by forming methanol and combusting methanol to have it. That is the indirect route, and it involves enthalpy of formation and enthalpy 2. Then we can then leave just directly from carbon plus hydrogen and the oxygen directly to carbon dioxide. This is the direct route, which is enthalpy 1. According to Hess's law, to form an equation using this, there is the direct root, which is this enthalpy 1, equal to the indirect root, which is the dotted line, that is enthalpy of formation plus enthalpy 2. When we do this, and we are looking for the value of enthalpy of formation, let's do it. Now, enthalpy 1 is the direct root. Indirect root will be enthalpy of formation plus enthalpy 2. This is it here. Now again, let's make this the subject. After doing this, we want to make enthalpy of formation the subject. So enthalpy of formation will be what? Will be enthalpy 1 minus enthalpy 2. Now that it is enthalpy 1 minus enthalpy 2, let's now substitute our values. The values for enthalpy 1 will be enthalpy of combustion for enthalpy 1 will be enthalpy of combustion for carbon, will be enthalpy of combustion for hydrogen. Now, the value of formation for enthalpy 2, the enthalpy of formation for enthalpy 2 will be what? The enthalpy of combustion for methanol. Let's substitute our values and see. Substituting our value for enthalpy of formation. Enthalpy of formation now. Enthalpy 1 now. Yeah, here. From enthalpy 1 now, enthalpy 1, I told you that enthalpy 1 is enthalpy for carbon and enthalpy of combustion for hydrogen. Now, this is it. This is enthalpy for carbon. This is the enthalpy of carbon plus enthalpy of hydrogen minus enthalpy 2 is enthalpy of combustion of methanol. This is the enthalpy of combustion of methanol. But remember, you have to take into consideration the number of moles. There's only 1 mole of carbon here. There are 2 moles of hydrogen here. There is only 1 mole of methanol here. So any value we have for any of them, we have to multiply by their number of moles. So we have only 1 mole for carbon. Taking the value of carbon and substituting it is just minus 394. We don't need to multiply, or multiplying by 1 means nothing. Excuse me. Then we have 2 moles for hydrogen. We need to multiply by the 2 moles of the hydrogen, and which is minus 286 times 2. Now we have only 1 mole for this, so the value remains. So remember, enthalpy of combustion for methanol is a negative value. Since it is negative here, it is negative minus, in bracket, minus the value that was given for enthalpy of combustion. So if we look at this value, and try to check at the answer column, what we are going to see will be, what we are going to see for this at the answer column, what we are going to see at the answer column for question number 6 will be negative minus 4 plus negative 286 times 2 minus into minus 726, and the answer for our answer, the right answer for what we have here, negative 772 negative this. The right thing we have here is our answer is negative 394 minus 286 times 2. Negative. Okay. What is question number 6? Negative 394, yeah, plus 286 times 2. That's good. Then again, negative minus negative 727. Negative minus negative 726. 726. That's good. 726. So if you look rightly, our answer for question number 6 is, this. Is C. Question number 6 is C. After solving the question very well using this formula, then apply it, that's Hess's law, apply it, draw it very well, deriving the equation and substituting the value, we will have that, and that will be our answer. So Hess's law, please always know how to solve this using Hess's law. Question number 7. Question number 7 has to do with a pair of numbers shown below. The pair of numbers shown below represent respectively the theoretical and the experimental lattice energy in kilojoule of a series of crystals. Which pair of these values best fit the simple electrostatic model of an ionic crystals? These are the pairs. The one that are too close together will be the one. The one that are too close together will be the one which best fits the simple electrostatic model of an ionic crystal. The one that are close together, the pairs of values that are close together. This one, there is a big gap there. D, there's a big gap. C, there is a big gap. 7, there is a 7 and a 9. There is a big gap. 630.9, 631. But this is too close, and A is our right answer for this. So A is the right answer for question number 7. Question number 8. In the determination of crystal structure by X-ray diffraction, the X-ray incident on the crystal are diffracted by A, atomic nuclei, B, electrons, C, neutrons, D, proton. Of course, the answer is A. Number 9. Crystal structures can be classified as either body-centered, cubic, face-centered cubic, hexagonal closest packed, or cubic closed packed. Which of the following information is true? Of course, from the closest, cubic closest packed, information is not right. From the hexagonal closest packed, information is not right. From the face centered cubic, information is not right. But from the body centered cubic, we know that it is there in a body centered. There are 8 and there are 8 corners there, and in one of it you can have at least 1.8 1/8 of it times the 8 corner. We will have we will have one atom, and if we go to if we multiply again 1/8 of the other body centered cubic, we will have another atom, and the number of atoms there are usually per a unit cell would definitely be 2, and there are usually 8 of there. There are usually 8 a coordination number in a body centered cubic. In a body centered cubic, there are usually 8. So if we are to have if we are to respond to this question, which of the following information is true, I will take A. I will take answer number A for the body centered to be A. It has 8 coordination numbers and 2 number of 2 atoms in a unit cell. So A is the right answer for this. I will go again to question number 10. Question number 10 has to do with boiling point. Question number 10 has to do with boiling point. I emphasize more on question that there are a lot of confusion there for the purpose of limitation of time. The boiling point of methane, ethane, propane, and butane are given. We have compounds, this methane, we have ethane, we have propane, and we have butane. These are their boiling points. Which statement explains the increase in boiling point from methane to butane? A closer packing of molecule result in stronger van der Waals forces. I've never heard that in chemistry. B, more covalent bonds are present, and therefore more energy is required to break the bonds. That is not the one that is accounting for the high energy that is required to overcome this bond. C, more electrons in the molecule result in stronger van der Waals forces. That is what chemistry tells us. That is the right answer. C is the right answer. I don't need to go further again. Remember that as the carbon chain is increasing, the molecular weight or the molar mass is increasing. The number of electrons are also increasing. There are about 3 points here. 1, as the carbon chain increase from methane to butane, the number of electrons are also increasing. The molecular weight is also increasing, as well as contact points. They are the contact points that matter. The contact points and the number of electrons. Why am I emphasizing on the number of electrons and the contact points? Remember that the electron cloud that is moving around the molecule will cause what? Will cause instantaneous induced dipole forces. Instantaneous. These are not strong electronegative or polar molecules. These molecules are not polar. For that purpose, there is what we call instantaneous, or what we call London dispersion forces. There is what we call instantaneous dipole induced dipole. These are caused by the electrons, by the cloud of electrons moving around the molecule. It comes at a certain time when the electrons they come closer to an unpolar molecule. What happens? They induce a dipole, and when they induce a dipole, what happens? A force. When it induce a dipole, what happens? There's now going to be what we call a force of attraction. When they induce a dipole, a partial positive charge on one end, automatically on the other end, there's going to be a partial negative. So now this is not going to cause the molecule to be polar. And when the molecule is polar, there's going to be what we call an induced dipole force of attraction. These are the forces holding the molecules together. These are the forces holding the molecules together. The more the number of induced dipole attraction, the stronger the forces. The stronger the forces, the more energy that is required to overcome the forces. So what causes them? So the more the number of electrons, the more the instantaneous induced dipole forces. And the more the instantaneous dipole induced dipole forces, the stronger the van der Waals forces. And the stronger the van der Waals forces, more energy is needed to overcome the force. And electrons can only increase with increasing molecular mass. So in that case, we are saying that electron will be increasing from methane. The number of electrons is increasing. The one here will be the one in methane. In ethane is greater than the one in methane. The one in propane is greater than the one in ethane. In ethane, and the one in butane is greater than the one in propane. So summarizingly, I am saying that as the carbon chain increase from methane to butane, the number of electrons increase as well as the contact points. The electron cloud moving around the molecule causes instantaneous induced dipole forces holding the molecules together to be stronger, and it will require more energy to overcome the force. So in that case, that was for the purpose of revision. So going to our column of answers, more electrons in the molecule result in stronger van der Waals forces. That is just all. When you see such things, one, check electrons, whether there are more electrons. If they mention more electrons there, and the electron increase by the increase in the molecular mass, then check the van der Waals forces. All of these instantaneous induced dipole forces, London dispersion forces, all the forces we are talking about, intermolecular forces, they are under what we call the van der Waals forces. All of them are under what we call the van der Waals forces. Van der Waals forces is what summarizes all of them. Okay, that's great. So our answer is C. For 10 is C. Question number 11. A mixture of propanone and cyclohexane forms a completely miscible liquid. The solution represents 1. An ideal mixture. B. A mixture that deviates from Raoult's law. C. A mixture that deviates negatively from Raoult's law. C. An azeotropic mixture. It is an ideal mixture. That is, the answer is A. Our question number 12. The two nuclei in hydrogen molecule are held together by the two nuclei in hydrogen molecule. The two nuclei in hydrogen molecule are held together by a mutual attraction between the nuclei. There's no mutual attraction between the nuclei. All the nuclei are positively charged. B, van der Waals forces between the molecules. C, electrostatic attraction between the nuclei and the shared electrons. D, mutual sharing of lone electron between the two hydrogen atoms. D is the right answer. D is the right answer. Now, D is the right answer. We have question number 13. The pH of a 0.1 molar solution of sodium hydroxide is A, 10, 12, 11, 13. Of course, now, what is pH? pH is a negative. pH is a negative log of hydrogen ion concentration. But in this case, it is an alkali. It is not. It is alkali. It is not hydrogen. So we need to calculate the concentration. What we need to do here is we will calculate the concentration of the alkali. It is alkali that we are seeing here. We will calculate the concentration of the alkali, look for negative logarithm of the alkali, then subtract it from 14. Subtract it from 14. We will have, because from 14, we will have that. Welcome back. Sorry for the interruption. We were on question number 13. The pH of 0.1 molar solution of sodium hydroxide is A, 10, B, 12, C, 13, and D, C, 12, 11, D, 13. Now, no, it is an alkali, and it's an alkali that has been given. And in this situation, to have the pH of this for this solution, we need to look for the negative log of the OH ion concentration, 0.1 molar of OH ion. So the negative logarithm for the OH ion concentration, when we have it, that will be our POH. Then we can have our pH by subtracting it from 14. This is just an example of this. This is sodium hydroxide. Sodium hydroxide gives us, it's an alkali. The OH ion concentration in it is 0.1, as we have been told. Now, negative logarithm of the OH concentration will give us a negative log of this will give us that is 0.1. It will be 1, and 14 minus this minus 1 will give us 13. So if we go back to our column, answer column, our answer will be D. So question number 14 has to do with a mixture of ammonia solution and ammonium chloride. Ammonium chloride constitutes ammonia and ammonium chloride constitute an alkaline buffer. Which one? This one and constitute an alkaline buffer. That's right. Yeah, the base and the salt. That is an alkaline buffer. Which one of the equations below represent the reaction of the buffer with a few drops of dilute acids. It is not A, the buffer, it is not really A, as you see. It is not B. Because they said a buffer with a few drops of dilute acid. Yes, with that one, it doesn't work. A does not work. B doesn't work. It's not with dilute acid, and it doesn't give a buffer. Equation that represent the reaction of the buffer with dilute acid. Okay, if you look at D, equation D, you will see there that, yeah, this, you will see there that with a few drops of this, which one of the equation below represents the reaction of the buffer with a few drops of dilute acids. Okay, ethanoate ion and hydrogen ion. Okay, ethanoic acid. You will see here that this is ethanoate on addition of a hydrogen ion, that is on addition of hydrogen ion representing acid, on addition of hydrogen ion representing acid, or we can lowering the pH of this solution by adding this hydrogen ion. What happens? The ethanoate ion will accept the proton. It will accept the proton and reform the undissociated ethanoic acid, thereby removing the hydrogen ion from the solution and restoring the pH. And that is how the buffer is working. So in this situation, D is the answer for 14. D is the answer for 14. Question number 15. Question number 15. We have question number 15 that has to do with given the standard reduction potential for the following half equation, for half reaction. You have iodine aqueous plus 2 electrons to give iodides. You have ion plus electron to give ion 2 plus, ion 3 to ion 2 plus, oxidation reduction. Now, using the standard electrode, standard reduction potential, it shows that from this reaction, it shows that ion is a beta oxidizing agent. Ion is a beta oxidizing agent. That means that it will accept electron and become reduced. It's a beta oxidizing agent that will accept electron and become reduced. So the equation here is good. Then for iodine to iodide, iodide shows that the reduction potential shows that it is a beta reducing agent. It is a beta reducing agent. That means that it will lose electron and become oxidized. It means that it will lose electron and become oxidized. That's why I say it from the value, the value of the reduction potential, it shows that It is a beta reducing agent that will lose electron and become oxidized. Okay, let me just go to what I am telling you. From what I am explaining here, let me just show you. From what I'm explaining here, I said this one is an oxidizing agent. It's a beta oxidizing agent. It will lose I will gain electron and become what? And become reduced. You know, oxidation is loss of electron. Oxidizing agent is acceptor of electron. So this is a beta oxidizing agent. For that purpose, it's going to gain electron and become what? Reduced from ion 3 to ion 2. So that is the equation. Now, I said the iodide from the equation is shows that it is a beta reducing agent that will lose electron and become oxidized. It has to lose electron, even though the equation and the other one did not show that it was losing electron. But from the reduction potential, it will have to lose electron for that. So the iodide, we have to write equation for that. In writing equation, it has to lose electron to become iodine. So there are 2 electrons of iodine here. We have to balance them. In order to cancel them here up, there are 2 electrons here. So what do? We need to multiply these other electrons up here by 2. So we need to multiply the reduction here by 2. So if we multiply by 2, we will have 2 ion 3, 2 electrons, 2 ion 2. And we need to add the 2 equation. This equation and this other one, we have to add them. We are adding all of them. We need to add all of them. We will add this equation and this other equation. So we need to add it. So on adding this equation, we'll have 2 ion 2, 2 ion 3 ion plus 2 iodide ion to give what? Because we already cancelled this one. To give 2 ion 2 ions plus iodine. This will be the reaction. This will be the Redox reaction. This will be the Redox reaction. The ion 3, which I said is a beta oxidizing agent, accepts electron and become reduced to ion 2. Meanwhile, the iodide, which is a beta reducing agent, will lose electron and become oxidized to iodine. So it is iodine here. The oxidation number is from minus to 0. There's oxidation. So this will be the equation. This is the reaction. And if we take this equation to our answer column, this is the equation at our answer column. We have 2 ion 3 plus 2 iodide to give 2 ion 2 plus this. I say 2 ion 3 plus 2 iodide to give 2 ion 2 plus iodine. And this is our equation that we are saying. This is a reaction. Which one of the statement is correct? So this is what is happening here. So D is what is happening here based on what we have written here. D is the right answer for number 15. Okay, let's proceed to number 16. Number 16 has to do with equilibrium reaction. Nitrogen plus ammonia, nitrogen plus hydrogen is an in equilibrium reaction gives 2 moles of ammonium. The enthalpy change is minus 92 kilojoule per mole. The equilibrium constant Kp for the reaction can be increased by equilibrium constant Kp. I want you to do something to know something. The equilibrium constant Kp. This is the equilibrium constant Kp. This is the expression for the equilibrium constant Kp. This is the expression for the equilibrium constant Kp. Kp is the partial pressure of ammonia divided by that of nitrogen times that of hydrogen. And the Kp, the value of Kp will depend on the numerator. The value of Kp will depend on numerator, that is, on the amount of ammonia. The higher the number of moles of ammonia, the higher the Kp. The lower the number of moles of ammonia, the lower the Kp. So what must we do to increase Kp? That is what you need to think. In order to increase Kp, the value of ammonia must, or the number of moles of ammonia must be up. The yield of ammonia must be up more than the one for the reactants. So what condition is required to increase the concentration or the number of moles of ammonia that will give us a higher Kp? In that case, adding a catalyst will not do us anything. Increasing the temperature will instead decrease ammonia concentration. Increasing the total pressure on the gas mixture at a low temperature, yes, because according to Le Chatelier's principle, we say that if a system in equilibrium is subjected to any change, the equilibrium or the system must react in such a way to oppose the change. If we increase the pressure, what happens? Why do I talk of pressure? Pressure is very important because this is a gaseous reaction. Reactants and products are all gases. So when we increase the pressure, the equilibrium will shift to the direction with lower number of moles of the gas. So between hydrogen and ammonia, the right side, the product side, which is ammonia, has a lower number of moles. So for that reason, if we increase the pressure, equilibrium, according to Le Chatelier's principle, equilibrium will shift to the right to lower the pressure. And if equilibrium shifts to the right, more ammonia is going to be produced. And if more ammonia is going to be produced, based on our equilibrium, equilibrium constant Kp, if more ammonia is produced, since Kp is equal to the ammonia divided by the ammonia divided by the denominator. So ammonia, the higher the number of moles of ammonia, there will be an increase in Kp. So if equilibrium shift to the right, increasing the concentration of ammonia, Kp is going to rise. And the equilibrium can only shift to the right if we increase the total pressure at a low temperature. So our answer for this is C. Question number 17. Question number 17. A reaction mixture. In a reaction mixture, if the temperature is raised by 10 degrees Celsius, which of the following is most likely to occur? A reaction. Remember, in a rate of a chemical reaction, when we increase in temperature will increase the rate of a reaction. But how is it going to happen? The final outcome is rate of reaction will increase. How does it occur? Remember that increasing the temperature by 10 degrees Celsius will lead to 1. Increase average kinetic energy of reacting particles. 2. Increase in the number of reacting particles or reacting molecules. The number of reacting molecules that have acquired energy which is equal to or greater than the activation energy now will increase. Since the temperature has increased, the energy in the system has also increased. So reacting particles more reacting particles will have access to energy. Therefore, we say there will be an increase in the number of reacting particles or reacting molecules that have acquired energy which is equal to or greater than the activation energy. There will also be increase in collision of particles. And when there is increase in collision of reacting particles, there is therefore an increase in the rate of a chemical reaction. So, that case, we will say what is likely to occur from this reaction towards as many collision takes place. I don't think so. The reaction, the activation energy is reduced by half. I don't think so. The overall enthalpy change will double. I don't think so. The number of molecules with sufficient activation energy will double. That is just what I told you. I said when there is an increase in temperature by 10 degrees Celsius, there is going to be an increase in the kinetic energy of the reacting particles. Now there's increase in energy. The number of the particles now, the number of particles or molecules will increase. Number of molecules with energy equal to or greater than the activation energy will increase now because the energy in the system has increased. So the number of molecules or particles with sufficient energy, that is energy which is equal to the activation energy or above the activation energy, will increase. There will be total collision. Collision will increase, and therefore there will be an increase in the rate of a reaction. So if we judge all this, the number of molecules with sufficient activation energy will double. D will be our answer. And furthermore, you could be given a curve like this one. So this is a reaction curve, number of molecules and the energy. This is the temperature by T. The section down here represent the number of molecules with an energy with energy. These are the number of molecules with energy, and these are the molecules that are reacting at temperature T degree Celsius. If we now increase the temperature by 10 degrees Celsius, this curve is the second curve here. The second curve here, you will see that the number of molecules has increased. This one in dotted form here. The number of molecules here have increased from this curve down here to the curve down here. The number of molecules have increased. There is a greater proportion of molecules than before that have energy which is equal to the activation energy or more than the activation energy. So the more the number of colliding particles and the greater the activation energy for them, obviously there is an increase in the rate of chemical reaction. So a curve like this could be given and you are asked to interpret. So this is such a curve. This is a curve that resembles the question that has been given. You see there is an increase in the number of molecules. You see the activation energy has also increased up. So now we say our answer for that is 17 is D. Let's go to 18. 18 has to do with the reaction rates. Yeah. Consider the reaction 2A plus B to give C. And it happens that the rate expression is given by rate equals to what? K, the rate constant K into the concentration of A and to the concentration of B squared. Now, we are saying that the order of reaction for B is 2. We are saying that increasing the concentration of B, the reaction will double. This one of A will remain. So now interpreting our result into the question, into the answers that have been given, This shows that the rate of reaction will increase 4 times if the concentration of B is double. No. The reaction rate will increase if the temperature of the reaction is increased. I don't think so. The rate of reaction will remain the same if the concentration of A is double. I don't think so. The rate of reaction will double if the concentration of B is doubled. I think that is the right answer. Okay, question number 19. Question number 19 has to do with maybe the periodic table. The periodic table. For the period lithium to neon, which of the following is a true statement? Period lithium to neon, that is period 2. That is period 2 of the periodic table, if I'm right. Period 2 of the periodic table. Lithium, boron, carbon, nitrogen, and I think neon, something like that. Okay. Which of the following is a true statement regarding this period? A. The atomic volume decreases across the period. Atomic volume cannot decrease across the period. First of all, there's nothing like atomic volume. Atomic, you can say atomic radius, not atomic volume. Atomic radius instead will be decreasing. It decreases to a certain level, then start it decreases for the metals. It decreases across the period. For the atomic radius increases for the periods. Why? Because of increasing number of protons. Okay, B. So A is not the right answer. B. The atomic radius decrease from lithium to nitrogen and then increase to neon. It increases from the atomic radius, it decreases from this to nitrogen, then increases to neon. Then increases to neon. In this case, it happens but with ionic red-eye. Ionic red-eye. The ionic radius will, what will do is, ionic radius will decrease from lithium, it will decrease for the cations. Then for the anion, it start increasing. So B is not the right answer. C, the trend in boiling point is similar to melting point, but values of melting point are higher. And that one is not good. The melting temperature increases from lithium to carbon. The melting temperature increases from lithium to carbon, and then decreases to neon due to change in structure. Yes. We know that as you move across the period, we are moving from giant metallic structure that have metallic bonds. Then we get to group 14. That is group 4. That has to do with carbon, silicon, and that group they have giant molecular structure. They have giant molecular structure. C in the case of silicon. C in the case of diamond. See, all those people in group 14, they have giant molecular structures. Then that is the highest. Then from there it starts dropping again, right to neon. Because of what? Those from there, that is nitrogen to neon. They have a simple molecular structure. They have a simple molecular structure with simple covalent bonds and weak van der Waals forces. So our answer is D. I said from lithium to boron, there's giant metallic structure. It is increasing. And it increases right to group 4, or what the modern periodic table calls it group 14, with carbon. You know, carbon has giant, carbon and group 14 elements, they have giant molecular structures that give them a high temperature. It gives them, require high energy to overcome the bond or the giant structure. Then from nitrogen right to neon, They are all simple molecular structures. And in that case, they have simple covalent bond that with weak van der Waals forces and they require just less energy. That is why it is decreasing. I just wrote something here. I think it can help you here. This structure can help you in that case. Something like this. If I'm not mistaken. Okay, I said from lithium to boron we have giant metallic structure. From carbon and then right to then carbon or group 14 they have giant molecular structures, and the neon to this they have simple molecular structure with weak van der Waals forces. So that is how the whole thing is. So our answer for question number question number 19. For question number 19, our answer is D. So melting point increases from this to carbon and then decreases due to change in structure. So from giant metallic to giant molecular and finally to giant to simple molecular structures. So D is the right answer, number 19. Let's go to number 20. Question number 20. Question number 20, with the element with the electronic configuration 1s2, 2s2, 2p2, 2p6, 3s2, 3p6, 4s2 is a transition metal. That is not a transition metal. It's not a transition metal. Why do I say it is not a transition metal? It is not a transition metal. It's not a transition metal. B, an alkaline earth metal. Of course, this is an S block element. The last electron is on the s orbital. Is an S block element, and the S block element has 2 electrons in outer shell. This is a metal. S block, they are metals, and with 2 electrons, it belongs to group 2 of the periodic table. And if it belongs to group 2 of the periodic table, it means it's an alkaline earth metal. So there's no need going further again. We say question number 20 is a B. 21. Which one of the following oxide is neutral? Oxide which is neutral, silicon dioxide. It is not a neutral oxide. It's slightly acidic. All group 4 elements, group 4 oxides are slightly group 4 or group 14, as the modern periodic table calls it. Slightly acidic. This one is beryllium oxide, this basic. Go to D, this amphoteric. And C, this C is what we call a neutral oxide. So that is a neutral oxide. It cannot react even with acid. It cannot even react with the bases. So CNO is a neutral oxide. Let's proceed to question number 22. Magnesium differs from sodium in that magnesium hydroxide is insoluble in water, while sodium hydroxide is soluble. Wow. Yes. B. Only magnesium will react with steam. No. C. Magnesium sulfate is insoluble in water. No. D. Magnesium carbonate is more stable to heat than sodium carbonate. No. The only feasible answer that shows magnesium differs from sodium is A, because the hydroxide of magnesium is insoluble in water, while that one, the one of sodium hydroxide is soluble. Remember the hydroxide of group 2 element, their solubility increases down the group. Their solubility is increasing down the group, implying that magnesium hydroxide is the insoluble hydroxide. So now I will say answer for question number 22 is A. Question number 23. Redox reactions are common in the chemistry of group 7 elements. We are talking of group 7, that is group 17. The modern periodic table calls it group 17. Now, you can still call it group 7, which are the halogens. Which statement is correct? Which of the statement is correct? Of course, we said redox reactions are common in the chemistry of group 7 elements. Which statement is correct? There's something you have to know about redox in group 7. Let me just brief you before we go to the answers. It should be remembered that the oxidizing ability or the ability to gain electrons. The oxidizing ability, I said oxidizing agent is the one that gains electron. So the oxidizing ability or the ability to gain electron decreases down the group. Fluorine is the most electronegative. It has the highest oxidizing ability, followed by chlorine, next by bromine, iodine, astatite. So the oxidizing ability, or what we call the electronegativity, the oxidizing ability decreases down the group. The halogen of the group will oxidize or will displace the ones below. For instance, fluorine will displace chlorine. Chlorine will displace bromine. In other words, fluorine will oxidize chlorine. Chlorine will oxidize bromine. Bromine will oxidize iodine. So that is how it is. The halogens of the group will oxidize the ones below or will displace the one below. Again, halogens down the group will reduce the ones above. Halogens down the group will reduce the ones above. For instance, bromine will reduce chlorine. Chlorine will reduce fluorine. Iodine will reduce bromine. Let's go to our answer column. Bromine ion will reduce chlorine. Are we on the track? Bromine ion will reduce chlorine, but not iodine. Are we right? I said the ones up will oxidize the one below, but the one below will do what? The ones below, the halogens down the group, will do what? Will reduce the ones above or up the group. The first answer, bromine ion will reduce chlorine, but not iodine. Perfect. Perfect. Let's proceed and see the other answers. Chlorine will oxidize bromine. Chlorine will oxidize bromine. But not iodine ions. Chlorine will oxidize bromine. Chlorine is of the group. Chlorine is of the group. It will oxidize bromine. It will oxidize bromine ion. But how can you say not iodine ion? Bromine will oxidize iodine. Chlorine will oxidize bromine as well as iodine. So the statement is right, and on the other hand, wrong. C. Fluorine is the weakest oxidizing agent. That is totally wrong. Fluorine is the strongest because oxidizing ability does what? It decrease down the group. Fluorine is the strongest, so C is the reverse. D, the iodide ion are the weakest reducing agent. That is even the reverse, because we are saying that the halogens down the group will reduce the ones above, implying that the reducing ability increases down the group. Those with iodine being the strongest reducing agent, but D is the reverse here. So the only answer is A. A is right in all the section. Let's go to question number 3. A is the right answer. Question number 24. Question number 24 has to do with group 4 or group 14. Question number 24. The innate pair effect is the reluctance of the outermost 2 electrons to take part in bonding. No. It is the reluctance of the outer 2s electrons. There are outer two electrons where? From the P, from the S, or from the D? No. Must specify. The answer was almost right, but it is wrong. You have to state the outermost 2s electrons. The outermost 2s electrons. That would have been okay, but because they did not complete it, wrong. B, only carbon and tin exhibit allotropy. Only carbon and tin exhibit allotropy. Only carbon and tin exhibit allotropy. Silicon, germanium, and lead exist only in one structural form. It should be noted that let's go ahead. The stability of the tetrachloride increases down the group. Instead, the stability decreases. The stability of the tetrachloride decreases because the bonds are becoming longer and longer. D, only carbon undergoes catenation. No. There are 2 elements in that group that undergo catenation. There is carbon and there is silicon that undergo catenation. Carbon and silicon are the 2 group 4 elements or group 14 elements that undergo catenation. So C is wrong, D is wrong, A is wrong. The only feasible answer is B. Question number 25. Transition element. Copper is a transition element with atomic number 29. Which one of the following statement is true? The electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3pd, 3ds, and 4s2. That electronic configuration is not right. It is not right. It is not right for it to be a transition element. It is not right. So B. Let's go to B. Its atomic radius is smaller than that of nickel, with atomic number of 28. Yeah. It has 29 and the nickel is 28. So it's nickel before copper. And we are saying that atomic radius does what? It increases across. We leave nickel before going to copper. So the atomic radius of nickel is smaller than that of copper. So B is saying that its atomic radius is smaller than that of nickel with atomic radius 28. The atomic radius is decreasing as we are going across the period. Across the transition period, the atomic radius are decreasing. So the atomic radius of nickel will be bigger or larger than the one of nickel of 28 will be larger than the one of copper of 29. Atomic radius is decreasing across the transition. It does not exhibit variable oxidation state. Transition method they exhibit, that's one of their characteristics. So it exhibits it. So that the answer is wrong. Did copper 2 compounds are more stable than copper 1? No. So the only answer for this, the only answer for 25 is B. Its atomic radius, the atomic radius of copper, which is 29, is smaller than that of nickel, which is 28. So B is the right answer. Why I say that the electronic configuration is not right, this is the electronic configuration for copper. This is the right electronic configuration for copper. I said know that from scandium to zinc on the D block element, the energy level of the 3D are reversed. 3D and 4s are reversed. 4s is at a higher level than the 3D. 4s is at a higher level than 3D. It's not 4s before 3D. It is 3D before 4s. This is because once the 3D is filled, the 3D electrons repel the 4s electron to a higher energy level. So this one, once the one is full, it repels the 4s electron to a higher energy level, that is a 4s. So the electronic configuration for copper is this one and not this, and not this one. Unlike what was given here as 3D9 4s2, it is not right. It's not right as a transition metal. It is not this one. It is this one. This must be filled, and when this is filled, what happens? It repels the one to a higher energy level. So this is the electronic configuration. Argon 3D10 4s1, not this one. So our answer for question number 25 is B. It takes us to question number 26. Question number 26. Which property of an atom does not affect its first ionization energy? Remember that there are about 4 or 5 factors that affect the ionization energy of any atom. We have the distance from the nucleus to the outermost electrons. We have the screening, or what we call the shielding effect of the outer electrons to the inner ones, that is protecting the outer electron from the attraction of the nucleus. We have the nuclear charge and other ones. So let's see if these ones are going to contribute to our answers. So which property of an atom does not affect its first ionization energy? Of course, the atomic radius. The atomic radius for question number 26. Atomic radius affects the property of affects the first ionization energy. The number of electron share affects the first ionization energy, because through shielding, as you go down the group, the number of shells are increasing. As the number of shells are increasing, the distance from the nucleus to the outer electron, the outermost electron, that what we're calling atomic radius, will increase, and the attractive force decreases. We call it the shielding effect. The number of neutrons have nothing to do with this one. The number of proton will have to affect the ionization energy, because the number of neutrons in the nucleus will balance the number of electrons. So that result in the charge. The more the number of protons, the higher the nuclear charge. The more the number of protons, the higher the nuclear charge. And the higher the nuclear charge, the higher the attraction of the nucleus to the outermost electrons, and more energy is now required to remove the first electron. So all these affect the first ionization energy of an atom, except neutron, which is C. Our answer is C. Question number 27. Copper forms the complex CuEDTA2-. Which one of is correct? The oxidation number of copper 2 is 2. ADTA has that's ethylene diamine diamine tetraacetic acid, ethylene diamine tetraacetic acid. The ethylene diamine tetraacetic acid, it has four ions. Let me write it here. Ethylene diamine tetraacetic acid, EDTA is this is CH2. We have CH2, CH2. I think there's nitrogen, ethylene diamine tetraacetic acid. Yeah, that is C. The minus C. Yeah, minus. That is a C. Yeah, minus. And there's a C 00 minus. So there's a double lone pair of electron here, a lone pair of electron here. So the coordination will be from, because there's a bond here, 1 2. Yeah, the coordination formation. Yeah, the coordination is from here, from here, from here, from here, from here. So it has a coordination number of 1, 2, 3, 4, 5, and 6 for ethylene diamine tetraacetic acid. It has a coordination number of 6. A coordination number of 6. 1, 2, 3, 4, 5, 6. Then, if we are to calculate the oxidation number of ethylene diamine tetraacetic acid is -2. Copper -2. That is, we have Cu EDTA. Yes, 2 minus. So if we are to calculate the oxidation number for this compound here, the oxidation state will be what? For CuE, EDTA, yes, we have this, and it's 2 minus. So we will say copper will be X. Let's say, okay, let's just say copper plus. EDTA has how many negative signs? Have 1, 2, 3, 4. EDTA has 4. Yeah, -4, -4. Altogether equals to the total charge out here, -2. EDTA has for this carboxylic acid, they have 4 carboxylic acid there, 1, 2, 3, 4, and they have negative, negative, negative. So they are altogether 4 of them. So now copper plus minus will be what? Copper will be equals to, when copper comes outside the gate, outside, it will be -2 plus 4. And copper now will be equals to what? Plus 2. Copper will be plus 2. So we will have a coordination of 6 and plus 2. A coordination of 6 and plus 2. And if we have that coordination of 6 and plus 2, our answer will be, let's start with D plus 1. No, the coordination number, it doesn't work here. C, the oxidation state of copper is plus, no. B, the oxidation state of copper is plus 2 and the coordination number is no. The oxidation state of copper is plus 2, that's good. And the coordination number of the complex is 6, exactly. So our answer for question number 27 is A. Our answer is A for question number 27. Our answer for question number 27 is A. So we will continue next time. Because of limitation of time, we still will have to continue the rest of the questions. So this is just what I have for you today. Thank you, fellow listeners. Thank you, learners. I'm wishing you good luck. Please, for those of you who have not subscribed, please try and subscribe for you to continue getting more of these resources. I still have more for you. Subscribe and get more of the resources. For those who have subscribed, I really want to appreciate you for a job well done for motivating us. Thank you. Wishing you good luck in your exams.